Always a ton of confusion around different types of compilers and interpreters and bytecode and how all that fits together. So in this video, we'll try to simplify all of that. We'll look at ahead of time compilers, JIT compilers, interpreters, and then languages that have compilers to an intermediate. What's up, engineers? So there's always a ton of confusion around different types of compilers and interpreters and bytecode and how all that fits together. So in this video, we'll try to simplify all of that. We'll look at ahead of time compilers, JIT compilers, interpreters, and then languages that have compilers to an intermediate representation. We'll talk about how all that fits together and maybe some fun facts along the way. So let's get into it. Just a couple of pieces of terminology to get out of the way before we begin. I'm going to use the term AOT and JIT a lot. When I say AOT, I'm referring to ahead of time, and when I say JIT, I'm referring to just in time. We'll start with the ahead of time compiler first because it's the simplest one out of all of them. The purpose of an AOT compiler is to take human readable source code and convert it to machine code that your CPU can understand. And as the name suggests, it's going to do this ahead of time before your program is ran. This compilation process will always produce a single native executable which you can then run. A few examples of languages which are implemented using this type of compiler are things like C, C++, Rust, and Golang. Next type of compiler is the JIT compiler, and this is a lot different than the ahead of time compiler in that a JIT compiler is not something that you as the user use on a source file. Just-in-time compilation is going to be an actual feature of an interpreter for a given language. So once you execute a human readable source file with a language's interpreter, that's when the interpreter will decide when it's time to just-in-time compile that source into machine code. So you might be thinking to yourself at this moment, well, if the language interpreter is going to compile the code to machine code while it's running, why not just compile it to machine code before it runs? And the reason is because languages that are implemented using interpreters that use just-in-time compilation are often languages that have dynamic and loose typing. And it's because of this dynamic and loose typing that it's not suitable for ahead-of-time compilation. Take the simple Python program, for instance. The reason this cannot be ahead of time compiled is because the size of name is not known at compile time. However, if it were to JIT compile it as it's running, it would first execute this because it does know the length of this string. It would ask you for your name. You would type it in. At this point, it would then know the length of name. It could then allocate the memory and assign it to the name variable, which you could then print. The whole purpose of JIT is to compile and execute things at the very last moment possible. And remember, it's worth mentioning that all this is necessary because your CPU only understands one thing, and that's machine code. Your CPU has no knowledge of Python or JavaScript, C, Ruby, PHP, or otherwise. A couple examples of languages that are implemented using a JIT compiler are newer versions of JavaScript, Ruby, and PHP, and then also the PyPy implementation of Python, which, by the way, is not the default. The default for Python is CPython, which does not use JIT, but we'll look at that a little bit later. Next step we're going to look at is just pure interpretation, and we need to make an important distinction here between this and an interpreter that uses just-in-time compilation. For the most part, any language that's not ahead of time compiled is first interpreted and sometimes just-in-time compiled. So in the context of this next bit, we're talking about languages that are just interpreted and don't implement JIT at all. One important property of pure interpretation is that compilation never takes place and conversion from source code to machine code never occurs. What does occur is that the interpreter will interpret the source code and then produce the desired result using its own facilities within its interpreter. So if the interpreter reads a source file that indicates that it should print something, it doesn't convert that print statement to native machine code. Instead, it uses the interpreter itself to just print something. PHP is perhaps the most well-known major example of a language that was implemented entirely with an interpreter up until recently. Although there's still plenty of use cases for interpreters today, they're largely being phased out in favor of JIT compilers simply because JIT compilation is faster in the long run. The last compilation process we're going to talk about is a compilation to intermediate representation with or without JIT using an interpreter. I know that was a lot of terms, but that's because the lines are really blurred between all the types of compilers with this compilation process, but just bear with me, we'll talk through it. The first step in this process is to take human readable source code and convert it to bytecode prior to running the program. And the reason this compilation process exists to begin with is to decouple the language from the execution environment. This is how Java handles its compile once, run anywhere kind of motto. Java code is first compiled to Java bytecode. That bytecode can then be ran on Java virtual machines, which convert the bytecode into platform-specific operations. And when I say platform-specific, I'm referring to Windows, Mac OS, Linux, and so on. By doing this, a Java programmer doesn't need to concern themselves too much with what platform they're actually developing for. They can just develop one source code for all of them. This is different than, say, a C programmer that has to take special care in certain circumstances to make sure their code is portable across all platforms. As far as the bytecode interpreters go, they're going to execute the bytecode in any fashion that they wish. And these interpreters are going to be very intelligent. They may or may not use JIT compilation when it's appropriate. In some cases, the interpreter may just execute the bytecode directly, or it may convert the bytecode into machine code and then execute that directly. Exactly what it does is entirely up to that interpreter. Some example languages that use intermediate representation are Java, C#, C++ when it's with the Microsoft .NET framework, and then of course Python using the CPython implementation, which is the default. Now note that C++ was also in ahead of time compilation, and that's because with Microsoft they're able to convert C++ code into intermediate representation, which can then run on their runtimes. This is different than compiling C++ with something like GCC or another compiler. So just to summarize everything again, ahead-of-time compilers will compile the code ahead of time before the program runs. Just-in-time compilers will compile code at the exact moment it's needed. Interpreters won't compile the code at all. They'll just look at the source code and then produce the desired results. And then languages that are implemented with intermediate representation will convert their source code into bytecode, which will later be interpreted by an interpreter, which may or may not use just-in-time compilation. I know this was kind of a complex topic. I hope I was able to explain it in a way that made sense to everybody. If you have any questions about anything you saw in this video, please be sure to leave them below in the comments. And other than that, I hope to see you in the next video. Take care.